Guys, on the table, on the screen here, we have two different kind of shorting: bubble short, selection short. What I did before was bubble short because I compare the two elements that sit next to together instead of comparing this element for this, and this, right? It's kind of hard to understand.
Play the bubble sort video. Let's see
Okay.
if we can see if that's what we've done.
Here, bubble shot, it compare the two elements next to each other always, and then it arrange the lesser to the left, the righter to the right. Okay.
You get the picture.
Basically, they also run two loops, two nested loops, and here selection shot. Okay.
Let's watch the rest of the algorithm play out.
Uh,
With 8.
no, I'm not going to. Okay. 5 here.
We're ready for the next iteration.
If you go to
This
3,
time, 3 moves into our sorted partition.
you go to 3, go to 9, go to 4, go to 8, and it will find the smallest one, and it put it in front 5. Okay, that's the difference. That's the only difference.
Let's watch the rest of the algorithm play out.
Okay.
Can you write?
Yep.
Given that we've all, well, some of us have done the bubble sort, can we write the selection sort?
Now we are going to do the selection shot, the real selection shot.
What is a big one? Is it a big one?
It's not flag, it's bubble shot in disguise. Okay. Sorry for that.
It's like yeah, it's a perfect.
This bubble shot.
Go to the board. Same thing. Interchangeable.
Okay, we are done. Bubble shot.
Then go back again.
Copy and paste. Bubble shot.
Oh, nice.
Nice, right? And here's the selection shot. We still have the loop for I in range of R. Okay. Now we mark the smallest number. Call it temp minimum index. Okay, equal to the first one, I. And then we run another for loop for j in range of we start from I and we end at length R. Okay, basically it's kind of like similar, right? You can start from I here too, same thing, and then we compare if R I, and then we compare with something here, and then we compare with R temp here. Okay, now which one do you want to use? Lesser or righter?
Where it was?
Okay, this one. Ray what?
On line 5, your array should find J.
It says BJ. Okay, sorry. And then if J is less than the minimum one, then we have to. Is it true? If this one is lesser than this one, we mark it. Okay, we mark it to the new J. Okay, and then after we've done everything inside this loop, we don't move out the loop. We swap the position. Array something, comma array something equal to array something, comma array something. Okay, and then we put the value in here. What should it be? I and temp min next. And his temp min next, and his I, and then we return R. It's very similar, but selection sort is we don't swap right away. We wait until the end of the loop, and then we swap.
Is there a reason you don't use J? Just because it can't access the new set J?
That's what. Yeah, I is always changing. You know, here, I is always changing. That's why we.
So that line on your the swap over part,
Which line?
it's not got line numbers.
This one?
On the part where you swap over,
This one?
there. So there's a reason you don't use J. You use temp.
Because we already assign this one to a new J.
So we're out the loop, but we're still able to call the variable on the left.
Because we are outside of J already here. We are already outside of the loop, a J loop here. Okay, that's different. You should see some indentation. We pay attention to the indentation. This is still inside the I loop, but out of the J loop.
The I has already been defined on that side. It's just saying about this.
Okay, to make it similar, right?
Oh, you just
Better?
changed it. Yeah, you just changed it.
No, it's the same. I just make it like wider to see, easier to see. So the swap here is outside of the J loop. Okay. Let's see. Let's go. Okay, run this. Now we have to what? Fuck. Yeah. Then we run everything again.
Let's run everything from the top.
You don't have to, but let's check. Okay. Okay, let's try it. Holy shit. All the integer scalar array can be converted to what the hell? Only integer scalar? What does this mean? We're wrong here. For I in range of len here. Run again. Can we just comment this so ugly? Okay, 181 milliseconds.
You didn't run the. What is it? Why didn't it say it's sorted? That's not printing whether it's sorted.
It's sorted.
The assertion, I suppose, it comes up with an error if its assertion is false.
It's true, right? It's true. And then here we gotta run this one, and we run this one.
So what's the difference between 53 and go above the one above? Yeah, do them both from 9. In fact, we'll do them both with 1,000 either way. Probably a fairer way.
Now we have to change to 1,000 now,
Probably a fairer way.
and then we have to is true. Then we can comment this one and this one. Let's see.
6, 5.
Kind of like similar, right? It's just a small margin. Okay, cool. Quick shot. You want break?
No.
No, we are out of time. We have to move on. Life is short. Quick shot. Have you ever? Okay. Basically, using quick shot, we are using a recursive function. Means like we are repeatedly call the function again and again and again until it meets the condition.
The function calls itself.
Yep. call
A
itself.
function that calls itself is called a recursive function.
So before that, you need a pivot, and then 3 parts. The lesser means like the elements, the array that contain the element that less than the pivot, and then the pivot, and then the okay, and then the right hand side.
ratio.
Okay. We have three parts. The left part, the middle will be the pivot here. The writer on the right side. Okay, blah blah blah. Brain explode. Okay. What the hell? So basically, we are keep trying to get the elements that the numbers that's smaller than our pivot, and put it on the left array, left hand side of the pivot, and the numbers that is greater than the pivot, we put it on the right side. Okay, and then we keep on running like that. So this is how it works. Wait. Let's watch the video. And I think the way this guy explained in the video is kind of weird. Quick. Nah. Okay, quick sort in 4 minutes.
Today, we're going to learn quicksort. Like merge sort, quicksort is a recursive algorithm. However, when you think of quicksort, I want you to think of the word pivot. A pivot is simply one of the items in the array that meets the following three conditions after we sorted it. First, the pivot is in its correct position in the final sorted array. This means that all items to the left are smaller, and all items to the right are larger. Let's look at an example. We're asked to sort the following array. Let's choose a pivot. I'll explain the best way to do this later, but for now, let's just choose 3. First, we move the pivot to the end of the array to get it out of our way. Next, we're going to look for 2 items. Item from left, which is the first item starting from the left that is larger than our pivot. Second, item from right, which is the first item starting from the right that is smaller than our pivot. Starting at 2, we can see that 6 is item from left. Now starting at the right, we see that 1 is item from right. Let's swap item from left with item from right.
Oh, really? No, you can move them free.
We repeat the process. This time, 5 is item from left and 0 is item from right.
They are swapping in order to save space.
Yeah.
Again, we swap the 2. One more time. This time we see that item from left has a greater index than item from right, so we know we're done. We swap item from left with our pivot.
The more confusing explanation.
3, our pivot, is now in its correct spot. To prove it, let's review our 3 conditions. As you can see, all items to the left are smaller, and all items to the right are larger. We said quicksort is recursive. Let's go through the process one more time with the larger partition we just made. We'll choose 7 as our pivot and move it to the end.
Split again.
I'll let you watch without voiceover. Now we have 3 and 7 in their correct positions. I think you understand the concept, so we'll let recursion handle the rest. One important question is, how do we choose the pivot?
I think you get it, guys.
It's too easy.
Done.
Okay, you understand the logic.
I
Then
get it.
here's the answer. It's confusing, right?
No, I can't understand it. So it doesn't care about the other ones. It wants
this
the same,
pseudocode is not intuitively reflecting the workflow.
Yeah, but that's a YouTube comment. Come on, who pays attention to that shit?
What? So how do you choose a pivot?
This guy, he suggests that we should take the first, the last, and the middle, and then we get the average. I don't know how he get an average. No.
That may be time visualization.
How? Like this.
But he found it hard. Let's not look at YouTube comments. It's literally 50-50 as well.
It's weird, right? Some people understand right, like less than 4 minutes. Some people are like, okay, the most confusing one. So here the pseudocode. Oh, so here's how to select the pivot. Worst case scenario, big O is n square. Same with the other one. N square.
For the average case.
Average case, if you choose the pivot correctly, the average case will be this. I doubt it. Where's it going? The lag.
So we leave the partition choice to a function as well.
Yeah, this is another function. You define it outside of the quick shot. Okay. You will have the exact example on how to do it here. That's how they enter into code.
Can you share that with us?
And this one actually runs slower than our versions. That I'm gonna do it right now.
Oh.
It's much slower. So where am I?
Why does it run a lot slower? Can you talk through both of them at the end once you've done yours and then compare it to that?
We will compare this.
Yeah,
with,
let's compare them.
Don't worry. Where are we? Here. So, here. Basically, we split it into 3 different parts, right? The array, 3 different parts. Let's say the pivot, call it P, equal to the first element. Let's pick the first one. Okay, the first element of the array, yeah.
Yeah, array 0.
0, yep. And then the left and the right. Left equal right equal empty array. Can you do it like this?
I don't know, we'll look at you.
Python is awesome. So, okay. Then here we're gonna run a loop for I in range of len r, and we're gonna split it if I is less than or equal to P. Then we put it to the left dot append R I. Okay, make sense?
Yeah.
Yeah.
No, that makes sense.
Elif R I else, just else.
Yeah, just, yeah.
Else right dot append R I. Okay. Then what else? We return. Awesome. We return right away. We return the left plus the P plus the right. Okay. But we have to call recursive function quickshot. So the left will be a new array, and the right will also be a new array. And here P here should be an array too. Okay. So our program here will automatically run the whole logic here again for the left. Inside that left, you will have, for example, another left and right, and it will call itself again and again until if r length r 1. Okay, we return r. That's it.
Well, what about one end?
Let's try it.
See, the only part I don't get there is at the end, just saying if the array length is only 1, then
You stop, just return the array.
Return.
Yeah.
but
The reason why we have to less, not just equal, we have less because sometimes it will split. The left hand side we have 1 element, the right hand side we have 0 elements. So we need to less or equal
okay.
1. Okay, now we check it. We run this shit.
When you return your quicksort array,
Yeah. We run this shit again. Holy shit. Maximum recursion. Huh? For if. Is it too much? Okay, and then we have changed to 100. Okay. Something wrong there? Quick shop left, quick shop right.
left not to be, doesn't need to be brackets that are array brackets. It's not something like that. The left is, it's already defined as an array, so that's okay.
Essentially, we continue one interview, so I also student did yesterday, this kind of maybe treat. Maybe show you stars.
Ma'am. Something wrong. Let's catalog it. Right, equal to this one. Then we bring it. Right. Yeah, I'm in the loop. What's wrong here? Else? It's weird. Gonna copy my old code yesterday. Is something wrong? We are calling this again and this one again. If length is lesser than 1, lesser or equal than 1.
If you do copy over your code from yesterday, let's keep this one up so we can then work out why this went wrong. So like,
Yeah.
just comment out and then print over your one from yesterday. What is the difference? Or not?
What?
I wanted you to comment out the code and compare them.
I just did it like
He did pick out his test, it's fine.
ขวา Same thing. Oh shit. Where is this? We should start from 1.
Each explain why that's a problem?
Why we start from 1? Let's say. See. We should start from 1.
Yeah, but explain that, not like,
Because we already picked the first one already. Right? So we don't start from the first one anymore, we start from the second one. So that's why.
but say for example you start from 7,
From
position 7 in your index.
position 7 in
So
my.
in an array we pick index 0.
Yeah?
What if our pivot was 7?
That's a good question. That's why this one doesn't work.
Because if you repeat the pattern again, it's gonna add more value to the array.
Yeah.
And then you always grow and grow. It's never end.
So that's why we were in a loop. So let's try with 1,000. Let's see.
Yeah, we were starting at 0 and then just continually
Yep.
adding on that array. It's the same result.
Here, 1,000 element take like 165 milliseconds to complete. Here only 12 milliseconds. Oh, much faster. And let's use the one from the Google, Mr. Google. What is this? Low and high. What the hell? Low, high. And let's call it quick shot with capital S here. And it takes 3 arguments, the array, the low and the high. Remove some of this. Okay. Let's change sort the array equal to sort. Okay, quick sort. Let's see, right? Actually, it's not gonna work. You need 3 arguments. Array low and high. What's low? What's high? What the hell?
First and the last.
Yeah, basically yes. So we need to define low and high. Quick sort my array, and we start from 0. We end with the length of my array. -1. Okay, let's see. God damn it! I have to click this. Okay, run again. None type has no length. This one has no length. What's error? Oh, here. For shorted. Because the function here, it doesn't return anything. It's just modify your array. It doesn't return on your array. So you can use this one. Remove this. Okay, now we test. It's not gonna work. Remove this one too. Okay, I don't know, man. The code from someone on the internet is bullshit. Okay, 37 milliseconds.
What was the last one?
Yeah,
12.
what was your
12.
But
And how do they choose the pivot in their version?
This one, you can tell.
the average. Average.
No. 0.
So they choose the same pivot point.
Actually, it's 0 minus 1. And then it's plus 1
No, no.
to go back to 0. It's kind of confusing, yeah. -1 means move it to the back. Remember, he picked a pivot and then swap it to the end of the array, right? -1 means the end of the array.
Yeah.
Okay. It's so hard to understand this one, but it still runs slower than the other one. Let's say, wow, like a copy of new array equal to copy dot copy deep copy of my array. Okay, and then we're gonna have another one. We are going to compare them, right? Quick, short. What's it been here? New R. Okay, and then we can tell different right now. God damn. Import copy. Okay, you can see different. 12 seconds for the quick shot, my shot. 32 seconds for the original quick shot. So it's faster, right? So there's one cons. There's a drawback. And what is it? Can you tell it from the code? It's much cleaner and shorter, run faster, cleaner code, and it return a new array, a sorted array. This one it modified the existing array. It's harder to understand, it's longer, but
Keeps the original array intact.
no, it's modified the original array. There's one pros. Our right here, our quick shot here, we generate new arrays, multiple new arrays, right? We generate a new left, we generate a new right for every loop. So yeah, it takes more memories, a little bit more. And then here, it just swap the position of the element inside the array. So there's pros and cons. Right?
So in what scenario do you think it would take for it to become better to use the bottom one over the top one?
I think the top one is better because we can increase the storage easily, but the runtime you cannot, right?
Buy more RAM.
Just buy more RAM, plug it in, or use a cloud service. Okay. Cool. Any question? Take a short break and move on to the merge shot, which is the most exciting one. I love it. Okay.